Welcome back to class time. I am Latoya Shiraya.
And I am Tyrone Brown.
And we are your CSEC math teachers for this session. Today, we're going to look at measures of central tendencies. All right, so as we said, today we're going to be determining measures of central tendency for raw and ungrouped data, grouped and ungrouped. When we talk about measures of central tendency, we're looking at a number that represents the central or the typical value of a data set. And we call those statistical averages. Now, the most common statistical averages that we look at or we talk about are mean, mode, and median. And we all know these. And so I'm going to ask Tyrone just to remind our viewers, what are mean, mode, and median? But before we get there, Sabrina, a friend of mine, she wants to start a small business where she buys and sells slippers in her community. She remembered her math teacher mentioning how statistical averages can help entrepreneurs, but cannot recall which of the averages could be useful in deciding what are the best slipper sizes to start her business with. Tyrone, now you and I need to remind Sabrina about the statistical averages and help her to decide which of those averages would help her to start her business right.
Okay, thank you, Latoya. Firstly, we have the mean, and that is a common average most persons are familiar with. It is a number which represents the typical value if the data set was equally distributed. Statisticians prefer to think of this as the central or balance point. The mean can be found by taking the sum of the data values divided by the number of data points.
All right.
This diagram below shows bars, which represent the cost of 6 toys. How can we use the stack of cubes to determine what the price would be if the toys were of the same price? We want to rearrange the cubes to a level price or make the price the same for each item.
All right, so basically you want me to level off the cubes?
Yes.
All right then, okay. So we have the cubes here. And if we were to level off all these cubes such that each of the toy would cost the same price, we will have each toy being sold at, is that $6?
Yes.
$6.
$6 each.
Okay, and then this now is actually a visual representation of what we mean when we say finding the mean of a data set. You basically want to find that value that would be fair across the board for everybody in the data set.
Yes, that is right, Latoya.
All
and
right.
You notice that each bar has the same value once it's evenly distributed.
Yeah.
So that represents the mean, or the average cost for one toy.
Okay. All right, mode.
Next, the mode is the most frequent number in our distribution. That is the number which occurs the most.
All right.
In this diagram, you will see that is also represented by the height, the highest bar in the distribution. If no number in the list is repeated, then there is no mode in the list. There can be many, or there can be more than one modal value in the distribution.
Okay, so you're saying that a data set or a distribution can have one mode, it can have no mode, or it can have more than one mode?
Yes, it can have many.
Okay, all right. Median?
The median is the middle value if this data is sorted in order, and it can be done in either ascending order or decreasing order. All data points are then, after sorting, you can pick out the middle value.
All right.
From those data points. And this is how we would arrange the data. So you would see the upper values that are unordered as it is right now, and then we go about ordering it, in this case, in ascending order, and then the middle value from that data set is the median.
Okay, so median, middle.
Yes.
All right.
If there are two numbers in the middle, we can take the mean of those two numbers, and that will give us the median.
And we know what the mean is from before.
Yes.
All right. So, back to Sabrina now. So, which of these measures of central tendency would best help Sabrina with her slippers business? Is it the mean? Do we need to find the average of the sizes that, are for the people in our community, their foot sizes? Or do we find the mode, which is the most number of one particular foot size? Or do we find the median, the middle value of the slipper sizes? Which of these now will help Sabrina to say, okay, I can use this value to tell me how to start my business?
Latoya, I am thinking if it is Sabrina wanted to cater to the needs of most of our customers,
right,
then she would want to find the one that most customers would want to buy.
Right.
And that would be the mode.
Definitely. So Sabrina or anybody else out there, if you're starting a slippers business, you want to buy the size slippers that most of the people in your community or your customer, that size that them wear. Thank me later. All right. Here's an activity. So we have some raw data here below, and this represents the number of deaths caused by coronavirus, COVID-19, during the week of November 8 to 14, 2020. And Tyrone, I wanted to tell the viewers and help the viewers to find out what is the mean number of deaths for the week November 8 to 14.
Okay. You're seeing basically on the distribution that there are 7 numbers there representing each day of the week, right? And if it is we wanted to find the mean, we would have to find the sum of all the deaths that occurred during the week,
right,
and divide that number by 7.
All right. So?
And that would be, as is here, 0 plus 3 plus 1 and so on, divided by 7, which is 10 divided by 7.
Okay, and that gives us a value of?
That gives us a value of 1.43, and that is going to be rounded to 2 deaths per week.
Wait, Tyrone, hold on here now. So when I find the mean, the exact value of the mean of the number of deaths for this week here is 1 and 43 hundredths, or 1.43. And you're telling me when you round that, you get 2? But what I know of rounding off is the fractional portion is closer to 1, so I round down and I would get 1. How comes you get 2?
Think about it this way, Latoya.
All right.
Suppose you and your family were going on a trip. Mm-hmm. There were 7 of you, but the car can only hold 5 persons at a time.
All right.
How many cars would you need to take? Would it be 1 car or 2 cars?
Okay, so 7 away, the car can hold 5. So I can put 2 in the trunk? No?
No, you can't put 2 in the trunk.
All right, so I'm going to have to take a second car. So I have 2 cars, 5 in 1 and 2 in 1. Or we can share it up any other way, but I'd have 2 cars.
Yes. So in that case, you realize that although the average would have been 1.4,
right,
we would still need to round up because we needed an additional car to hold the excess people.
Oh, so we have to account for those persons. We can't just leave them.
Yes, we can't just leave them.
I got you. Okay. All right. So then what is the modal number of deaths for the week?
In this case, you would see that 2 is the number that is most frequent.
Right.
Therefore, the modal deaths for that week would be 2.
Okay. Easy. I see 2 coming up more or most, so definitely. All right. And then the median number of deaths for the week.
As we had discussed earlier, first, this data set is not in a good way for us to actually analyze our median.
Okay.
We would need to arrange it in some order.
Okay.
So we'll go ahead and choose the ascending order.
All right, no problem.
So as it is, we are arranged our data in ascending order, and I am seeing the middle term to be another 2. 2 to be the value for the median.
Okay, so our median is 2. So our mean is 2, our mode is 2, and our median is 2.
Yes, so What is that saying to you?
Well, as we stated before, all three of these measures of central tendencies are actually averages. And if I'm getting that all three values are the same, then that will tell me that approximately 2 persons were dying per day.
Yes.
For this week.
Yes.
For this week.
Yes,
for
definitely.
the week of November 8 to 14, I believe. All right. All right, Tyrone. So as the student council representative or president, Nicola approached you about the challenges faced by the students in her grade 10 history class. She mentioned that the entire class was not doing well, and the class average was below the 60% mark. So I'm going to show you a frequency table of the results, and we need to discuss if Nicola has a legitimate concern. Is it that all the students or a majority of the students are not doing so badly and they need some intervention over that grade 10 class? So here is the frequency table. How can we help Nicola here now?
First, I think we'd need to get some more information.
Okay.
So I think we'll start off with the range of scores.
All right.
And the range is the spread of values in a data set.
Okay.
And in this case, the range of values would be 80 minus 0, which is 80.
All right. So why we do 80 and 0?
Because we're taking the highest score that the students got in the class, which is 80.
Right.
We're subtracting from that the lowest score, which is 0.
Okay, so we're looking at the two end values, highest and lowest, and that will determine the spread of values, like how far apart the first value is, the lowest is from the highest value.
Yes, and it's also giving us an indication as to the difference in the performance of the students.
The gap.
So you had some students who are doing really well and some who are doing really poorly.
Okay. All right.
So next, I think we'd want to look at the mode.
Okay. And we're seeing that the mode from this table is 70. I get 70 because I'm seeing from the frequency of all the percentages, 70 have 15 students getting a percentage of 70%.
So most students got 70.
Most of the students were getting
Yes.
70%.
So that would be the mode for the class. Most
All
of
right.
them getting 70.
Okay.
Then we'd want to look at also the median.
All right.
And there's one way for us to look at it in terms of looking at the way we did before, finding the sum of all the data values. Here you will see.
No, ma, we list out, yeah.
We're listing all the data values, yes.
In ascending order from smallest
in this
to
case,
highest.
and we're trying to find which one falls in the middle
All right.
of the distribution.
So we're count from the front.
I'm seeing
and
here
the
probably
end.
about 30, so it's about 15th and 16th element, which falls in the middle.
So we have two values in the middle. And I remember earlier you said when we have two values in the median position, then we find the mean of those two values. And we do that by just simply adding and dividing by the number of values, which is 2. And we will get back 70 in this case. It might not always be, if you have two different values, then you have to actually, when you do the calculation, it might not end up being one of the values from the middle. All right?
Yes, I completely agree.
All right, so what do we do next?
So finally, we'd want to know the mean. And
All
that
right.
was what Sabrina was talking about.
Okay.
Nicola was talking about.
Yes.
Yes. So again, we'd want to find out the total value or the total score for all the students in the class. And we can go ahead by, in this case, we want to add up all the score. But we
Right.
find there are 3 of the students who got 0.
From the table, we can see that.
We can see that. 2 of them getting 40.
Right.
So that's 80. 2 of them also getting 50 and so on, right?
So I'm seeing you on here, we're multiplying the frequency by the score.
Yes, and that will give you the
Total.
the subtotal for each group of students.
Okay.
So the group of students who got 0, the group of students who got 40 and so on.
Okay.
So the overall total for all the students was 1,770.
Okay.
And we divided that by 30 because there are 30 students in the class.
Right.
And that will give us a mean of 59.
All right. And Nicola did say that the average for the class, and I'm sure she was referring to the mean at that time, is below 60. So here we're seeing that the mean is 59, the mode is 70, and the
Median was 70.
The median was 70.
Yes.
But so here we're having now two different values. So we have 270 and we have a 59.
So it's for us to determine which is going to be our most appropriate in this situation.
Right.
If that 59 or the 70 would best represent the data set.
But does Nicole have a legitimate concern though? Is it a case where the entire class is performing below par?
No, I wouldn't say all the students in the class are performing below par because as you can see, there are approximately 23 out of the 30 students who passed the exam.
Okay, so we're having 5 students getting 60, 15 getting 70, 3 getting 80%, which that is 23 of the 30, which suggests that more students of the 30, because 23 in comparison to 7 is more. So we have more students actually performing up to and above par.
Yes, yes,
But
they were.
why the mean, though, is so low?
I'd want you to pull your attention to the students at the lower end of the distribution. Those 3 students who got 0.
Okay.
You realize that because their values, the score that they got was so far below everybody else, right? They are the ones who are actually pulling down the distribution. And we call those values that are extremely below or extremely above a distribution, extreme values or outliers.
Okay, so I have the solution for Nicole. She needs to go and talk to those 3 students who got 0, and maybe the 4 that got 40 and 50. So the mean then might not be a good representation of the data set sometimes.
Yes, because if we excluded those 3 persons, we definitely get a much higher mean.
And and it would have a better class average, and it wouldn't look as if the entire class is performing badly.
Yes.
Okay, all right. All right, so here we have another activity. David, must be my son, grew some carrots to make some extra money. He dug up 50 of the carrots and measured their mass to the nearest gram. And here I have a table, a frequency table representing David's carrots that he dug up. So I'm seeing, and if you were here last week Friday, you will remember that we spoke about creating frequency tables using class intervals. So we're seeing our class intervals in our left column and the frequency for the carrots that fall within those class intervals. All right, so we need to find the modal class and we need to determine the mean mass to the nearest gram for this data set. All right, Tyrone, help us now.
Okay. As you would have mentioned before, we're asked to find a modal class.
Right.
But we had done some discussion before about what the mode is.
Right.
Can you remind me what the mode was again?
The most frequent value in the data set.
Okay. And the class interval, because we're talking about a class in this situation.
So it's mode and class come together.
So it is the mode and the class combined together. So we're looking for the class with the highest frequency.
Like that.
Yes.
And from the table, we can clearly see that that is 60 to 64 grams interval.
Yes, that is
because there is a
good.
20 of the carrots would have weighed between 60 to 64 grams. All right.
So that class interval is the modal class.
All righty. So we talk about the modal class. We're talking about the class interval with the highest mode or frequency.
Yes.
Yeah, the highest frequency, sorry. All right, so we need to now find the mean mass to the nearest gram. How we do this now?
You're looking at the data, right?
Yes.
Can you remind me about something? Do we know exactly how many of those 7 carats were 50 and how many of them were 54 grams?
I was just about to ask you because I wasn't there when David was weighing the carrots.
So we are finding ourselves with a little problem because we are not sure exactly how many of them were 50 and how many of them were 54 grams in mass. So therefore, we'll have to use another value as an estimator for the mass of those 7 carats in the first class.
Okay.
And for that purpose, we're going to be using the midpoint.
Oh, okay. All right. The midpoint. And we did speak about the midpoint last week, Friday. But just a reminder, if you don't remember, and for those who weren't here, the class midpoint is found by summing the lower and upper class limits and dividing that by 2. Or you can just say finding the mean of the upper and the lower class limit for each class interval. All right? So we're just going to do that quickly. So for the first class, or midpoint would be 50 plus 4 divided by 2, right, Tyrone?
Yes, so that would be 52.
Right. And then for the second class, we have 55 plus 59 divided by 2, which is?
57.
Tyrone, you're bright, man. 60 plus 64 divided by 2, that is?
62.
62.
Oh, but that's all, yeah. I'm seeing a trend.
Yeah?
I'm seeing that the midpoint seems to be increasing by 5. What could be causing that? I'm already seeing something because 5 plus the 52 gives us 57 and 5 plus the 57 gives us 62.
Okay, and I'm also seeing where the class intervals have a size of 5 in each interval. Oh, the class width.
The class width,
the
yes.
Class
the
width.
class width is also 5.
So that means then that if our class width for our intervals is 5, that means the difference in our midpoint, the width there in the midpoint is also 5.
It's also going to be 5 because those are the values that we use to determine the midpoint.
Ah, I see. All right.
So it will have the same distribution.
Okay.
So those are the estimates for the value of the mass of each carat in the different classes, right? So we'd want to find out the total mass of all the 50 carats.
Yes.
So we have 7 carats, each having approximate mass of 52 grams. So how would we go about finding the mass for those 7 carats?
Well, seeing that we're using the midpoint, and we can just multiply.
Yes, because we are saying each of them is 52.
Right, an estimate,
yes,
right.
7 times 52 would give us the total for those 7 carats.
Okay, so all right, let's organize it a little. I think I want to call the frequency column F. And we're going to call the midpoint values X.
Yes, because that will help us in terms of the discussion.
Right, and so we are now finding F times X to get the total mass for each interval.
Yes.
All right, so when we multiply now our F and our X's, these are the values that we will get.
But you're realizing that we are just getting the values for each class.
So we still now need to find the sum of the entire data set.
Yes, we need to go about doing that.
So we'll just add up the values from our F times X column. And we already know that the number of carats is 50, but we're still adding the frequency to show that it is 50. All right?
And when we do the division, we are getting approximately 60.4.
All right, but it asks to the nearest gram.
Yes. So if it is that we're going to be rounding this off, for the mass of each carat that David dug up, it would be approximately 60 grams for each carat.
Okay, so each carat is weighing approximately 60 grams. If we were to level off, as we said earlier, so each carat can weigh the same. Okay, all right. Wow, Tyrone. But, Tyrone, earlier when we spoke, we rounded off 1.43 or 1 and 43 hundredths.
And we got 2, right?
And we got 2. So now we're rounding off again, and it's basically the same 0.4, but we round down. So how comes we round up earlier and now we are rounding down?
Okay, in the first scenario, we were looking at what type of data set. That's what we need to think about.
Okay, the first scenario we're looking at number of deaths, so that's discrete because it
was discrete, and we spoke about that last week in terms of the difference between discrete and continuous data.
Yes, we did.
Okay, so that was discrete, and we realized that for the discrete variables, once you would have passed a value, you would have to round up to get to the the next discrete value above it.
Oh, because you have to account for the individual values.
Yes, for the remainder. That happens after the division.
Okay, and in that case, we were talking about the number of deaths, and even though we don't have a fractional person, and we still have to account for that person.
Yes.
So we have to round up in that case. All right, so talk to me now about this value. So we're talking about mass here.
Yes, in this case, we're looking at a different type of data set. And what type of data set are you basically seeing
All right,
here?
so we're talking about the mass of carrots and measuring. And last time when we talked about measurement, those values are continuous data set values, all right?
So that would be a continuous data set. We could have left it as 60.4, because that would have been an acceptable answer.
Right.
If it is we weren't asked to round it off to the nearest whole number.
Okay.
But in this case, because we're asked to round it off to the nearest whole number, and it is a discrete data set.
Continuous, sorry. Yes.
It's a continuous data set. We'll use the same rules that we'd have learned about rounding.
Okay.
Once it is, you would have been below 0.5 or halfway, you would round down.
Okay. So what you're saying, what I'm getting from you now, Tyrone, is that for the discrete data set, we have to take into consideration all of the values. So you don't have half of a person, you don't have half of a foot, but a shoe, one in your foot, or a half of a dog. So we're talking about those discrete values. You have to take into consideration the other number. So you want to round up to account for those.
You wouldn't have fractional
values.
figures, so you'd have to round up to account for those that would remain after the division.
Okay, and then now when we're talking about continuous data, we can stick to the regular rule of rounding off, which is if it is closer to one value, we round up, and if it's closer to the lower value, we round down.
Yes.
Okay, no problem. I hope you got that at home. All right, so here we have a CSEC question, and it says the table below shows the number of goals scored in 25 football matches. And here we have the table, and they want us to find 1, the modal number of goals scored, and 2, okay. We're finding the modal number of goals scored.
Let's start with the first one, yes.
All right.
So, the data is not how we would normally see it, right?
Right.
Because they're asking us for the number of goals scored, right? And that the frequency in this case would be the matches, the number of matches.
Right.
So I want everybody to pick up where the frequency would be, which would be the number of matches.
So you don't always see the word frequency on a table. So when you get the table now, you have to determine which of the values represent the frequency
and which represents the data.
Okay. All right. So in this case, the number of matches will represent the
frequency, and the data would be the number of goals scored.
So wouldn't the number of goals scored be the frequency?
No, because you're trying to find out how many goals scored. Right?
Okay.
How many goals scored. So if it is, I had a match, say for example, I had 7 matches, and 5 goals were scored during that 7 match.
Okay.
Then the number of matches in which 7 goals were scored would be 5.
Oh, okay. All right. Okay. So, what is the modal number of goals scored?
So we're trying to look for the highest frequency first because we're looking for a modal value, right? So that is the first thing we're trying to pick up, the highest frequency. And we're saying the number of matches gives us the frequencies.
Yes.
Therefore, I'm seeing the largest value in that to be 7.
Okay.
So the highest frequency is 7.
All right, so that means that also, so the highest frequency is 7, and that is for one goal.
For one goal.
Okay.
So one goal occurs in most of the matches
Okay.
that are being played.
Okay, so that means that the modal number of goals scored would be 1 goal. All right, got you. I hope you at home are getting it as well. What was the median number of goals scored? All right, so we spoke about earlier that we can look at listing out all of the goals,
values.
all of the values in the data. But if we have the data already organized in a frequency table, we don't need to list it out. What we need to find is the middle. So we know that is 25 football matches, and where would that middle number fall, that middle number of goals?
I am thinking half of 25 matches would be 12.5.
All right.
But it's an odd number, so I know that one number will be in the middle.
Right, so it will be in the middle of 12, the 12th and the 13th.
Yes.
Okay,
So,
match.
So it's actually it's one number, so it's going to be between the 12th and the 14th. So it's actually going to be the 13th value.
Okay, oh, yes.
Because it's only one number that will fall.
It's one
so you'll
number.
be having a 12 on one side,
12 on the other side,
and then the
one in the
25th,
middle.
One in the middle.
Okay, all right. So that would be what now?
So we're trying to find the 13th element from the data set, and we're starting from the ascending side. Let's start from that side.
Sure.
So I'm seeing 5 of them got 0, so that
No goal.
Yes, 0 goals, and 7 of them 7 matches would have 1 goal. So I already have 12 matches so far.
Okay.
And I need one more match to reach the 13th match.
Right.
So that would be one of those matches in which 2 was scored.
All right, so I'm trying to visualize it now. So I'm not going to write in, so I'm trying to visualize it. If I'm supposed to write out the values in ascending order, I'm going to write 5 zeros first, and then I'm going to write 7 ones, because I'm writing out the data values now, And so that is already 12 values right there, so.
And we need one more.
And we're looking for the 13th value. So that 13th value position, I would be writing a 3. Is it?
A 2.
A 2, sorry, yes, a 2.
We wanted to know the number of goals scored in that
2.
match.
Right, so
it would be 2.
So that means that the modal number of goals scored would be?
Median.
The median?
Yes, the median in this case would be 2.
Yes, the median number of goals would be 2.
And that would be scored in the 13th match.
And that would be scored in the 13th match. So just to repeat if you're feeling a little bit confused. Here we go. So you can find the median by writing out the values in ascending or descending order. But that's if you have a small number of values. You don't want to take all the time writing out all the values. So if you already have a frequency table and your data is already organized, this is what you need to do. You're going to find the middle position for your median. Now in this case, we have 25 football matches, which means that our median would be in the middle of 25. And we know that the median, which is dividing by 2 there, would be 13. So our median would be in the 13th position. So looking at the number of goals scored now, we want to find out which of these number of goals will fall in the 13th position. So we already have 5 zeros, no goal, 7 matches scoring 1 goal, and that is 12 matches already. And we now want the 13th position. And so 2 matches with 2 goals would fall in the 13th position. See if you can visualize it with me. If you can't, write it out and see if you can see what I'm saying. All right, so our median number of goals would be 2 goals. All right. Okay, here is another CSEC question. So we have a class of 30 students counted the number of books in their bag on a certain day. And if it is when I was going to school, oh my God, my shoulders used to hurt me with the number of books you have to carry.
Yeah, some people had a whole heap of
Listen,
books.
man, this online learning here is good for our shoulders and our backs. I tell you, for the kids, that is. All right, so using the table that I'm going to show you soon, we want to find out the total number of books, and we also want to find out the mean number of books in each bag. So we want to find out, you know, the average number of books that is in each student's bag. If each student was supposed to have the same number of books, how many books would in each of the person's bag? So here we have our frequency table that is showing the number of books in 30 students' bag.
And as we would have done before, we would have to find out how many would be in each group, right?
Okay.
So we had 2 students having 1 book in their bag. Mm-hmm. That would be a total of 2 books.
Right.
And you would have 3 students with 2 books in their bags, and that would be 6 books.
I'm seeing a little error on our projector here, though, because what the tally is saying 3. We're having 3 strokes for the tally.
Yes.
But the frequency is actually saying 2. So that should have been 2 strokes for the tally column.
Oh, okay.
Right. So we actually have 2 persons with 1 book in their bag.
And we have 5 students with 3 books each. That would be 15 books for those 5 students. And we can continue going down, and that will give us the number of books for each of these groups of students.
Right.
So in order to find the total number of books for the entire class of 30, we would need to go ahead and find the total of that column that says frequency times midpoint. Frequency times X.
Frequency times X. Okay, no problem.
Or frequency times the number of books.
All right, so the total number of books in all the 30 students' bag is a whopping 127 books. Wow, for 30 students?
127 books, yes.
Jeez, my shoulders start hurting me already.
That's a whole lot of books.
100, and
But
by
that's
the
for
way,
the entire class still. So
but that's 30 and each book might be so heavy.
I'm not too
Them
too
chemistry
concerned
books
about.
are heavy, man.
Okay, so we need to go ahead now and use this information to find out the mean number of books.
All right. And
So
I wonder if they can find it out at home.
they should be able to.
They should be able to. Find it out at home, post it on Facebook, tag TVJ, and we'll know if you got it right. All right? That's the time. Unfortunately, we have for CSEC Mathematics. Up next, Cape Communication Studies.